Hey makers, welcome back to Hub360 Embedded Sphere, your number one spot for embedded systems, robotics, and affordable electronics. In today's video, we are doing hands-on performance comparison between two of the most popular motor driver modules for hobby robots, the DRV8833 dual H-bridge motor driver and the classic L298N motor driver module. And instead of using different robots, we are keeping this comparison scientific and fair by testing both drivers on the exact same two-wheel drive robot chassis. You will see how each driver performs in speed, torque, battery efficiency, heat, noise, low speed control, and smoothness of PWM control. As always, all components featured in this video are available at hub360.com.ng, tested, affordable, and shipped nationwide. Let's get started. This project is simple. We take one single two-wheel drive robot and power it first with the DRV8833, then disconnect it and power it again using the L298N. This way, same motors, wheels, weight, battery, and load. So any difference we see comes entirely from the motor driver. First, let's try and understand the motor drivers we are using here. The DRV8833 is a compact, efficient dual H-bridge motor driver and uses MOSFET power stages. It gives smooth, quiet motor control and performs extremely well on battery-powered robots. The key features are it supports 2.7 voltage to 10.8 voltage for the motors, and then up to 1 amp per motor. Then it's very efficient. It's MOSFET based and it consumes low power, which means low heat output, smooth PWM control, and small form factor. Great for two-wheel drive robots. Then the pinouts for this driver is one, we have the VM pin, which is the motor power. And then we have the VCC pin, which is connected to 5 voltage logic. Then we have the A in 1 and A in 2 pins, which is connected to motor A control. Then the B in 1 and B in 2 pins, which is connected to motor B control. A out 1 and A out 2 pins is connected to motor A output, while B out 1 and B out 2 pins are connected to motor B output. The end slip or enable pin is connected to power. Now let's also understand the L298N a little. The L298N is an older but very popular high current motor driver with a built-in 5 voltage regulator. It handles bigger motors but wastes more power and runs hotter. The key features here is it supports 5 voltage to 35 voltage on the motor, and then up to 2 amp per motor. Strong low speed torque, and then it has an onboard 5 voltage regulator, very beginner friendly, larger and heavier than the DRV8833. The pinout for this driver is, we have the 12 voltage pin, which is the V in pin. Then we have the 5 voltage output pin, which is regulated to 5 voltage. And then we have enable A and enable B pins, which is an PWM speed control. The in 1 and in 2 pins are for motor A direction, while the in 3 and in 4 pins are for motor B direction. Out 1 and out 2 pin is for motor A, and out 3 and out 4 for motor B. Now in this project, the components we use are one Arduino Uno, a DRV8833 motor driver, one L298N motor driver, one two-wheel drive robot chassis, one HC05 Bluetooth module, and one battery pack, jumper wires, and then breadboard, which is optional. All these components are available now at hub360.com.ng. The control method we'll be using for this project is that we'll be controlling it through wireless Bluetooth, and we'll be using the serial Bluetooth terminal app on our Android. We'll be using commands like forward, F for forward, B for backward, L for left, R for right. And let's see how the DRV8833 handles a two-wheel drive robot. We'll be controlling the robot wirelessly using the serial Bluetooth terminal app on Android. I'll be using commands such as forward, F for forward, B for backward, L for left, and R for right. Now that the DRV8833 test is complete, let's disconnect it and wire up the L298N to the same two-wheel drive robot. Now let's test the L298N driver. Same two-wheel drive, same battery. Let's go. We'll be controlling the robot wirelessly using the serial Bluetooth terminal app on Android, same as we did with the DRV8833 driver, using commands like forward, backward, left, and right respectively. Okay, from the test drive, using the DRV8833 driver module, we experienced very smooth acceleration, quiet motors, low heat, great low speed accuracy, fast forward movement, and long battery life. The DRV8833 gave us a fast, smooth, efficient performance, exactly what it's known for. Now from the test drive using the L298N driver module, we experienced strong low speed torque, slower top speed, noticeable motor noise, more heat after 1 minute, higher battery consumption, less smooth PWM, it's bulky and heavy. As expected, the L298N feels more powerful at low speed but less efficient overall. Here's a detailed side-by-side comparison. Let's break it down clearly. The DRV8833 advantages are faster on two-wheel drive, it's much cooler even with load, very smooth motor control, it's quieter, smaller and lighter, uses less battery power, and then great responsiveness. While the advantages for the L298N are stronger torque at low speed, handles higher voltage motors, built-in 5 voltage regulator, and then very beginner friendly. My final notes are on a small two-wheel drive RC car, just as we use here. The DRV8833 clearly outperforms L298N in speed, smoothness, and efficiency, while the L298N shines only when using larger motors or heavier 4WD robots. So after testing both drivers, the L298N shines only when using larger motors and heavier 4-wheel drive robots. So after testing both drivers on the exact same 2-wheel drive robot, the results are clear. The DRV8833 is the winner for small robots, precision, and battery efficiency. The L298N is better for higher voltage or heavier robots that need raw torque. Both are great modules. You just need to choose based on your project needs. Get both motor drivers today from hub360.com.ng, delivered anywhere in Nigeria. Thanks for watching Hub360 Embedded Sphere. If you love this comparison, hit like, subscribe, and ring the bell for more embedded projects and robotic tutorials. See you in the next video.